Um, we're just talking about plans for um, spring break. Anybody have anything going on? Yeah, I can imagine. Yeah, you don't have to endure the music. Your family or have the same music tastes you do, Rachel. Hi, Kylie. Because I like a lot of different music. I'm getting to like my grandkids' music, but there's a chicken song that's techno chicken that they love. I can't stand it. Hey, Gabby, good to see you. Techno chicken. Yeah, they're funny. So okay, yep, lots of music. Yep. Yeah, I should be playing more music on here, but I get distracted too easily. So let us do this quizzes today. This is just a review of the vocabulary for this week. So don't have an awful lot of time because of the fact that we have only got 3 days, and Friday is an asynchronous day. So lots of vocabulary work. 8 vocabulary types of energy. You got those in your notes, but let's practice those real quick. If you can get in there, I appreciate it. Hey, Journey, good to see you. DeAndre, happy went happy Tuesday. I wanted to say Wednesday. Thanks, Grace. Anybody else in there? Thanks for participating, guys. Really does make it a little more competitive, lots more fun, and also hopefully you're taking these notes and putting them in your flashcards or notebooks so that you can, and then you can also submit those to Offline Tracker. Thanks so much, guys. So we got 1, 2, 3, 4, 5. It's almost half the class. Anybody else want to jump in there? Get the vocabulary practice here. Yeah, well, Friday is asynchronous. Yep. They have not told me that it's a teacher work day for us, but trying to get the grades in. But they want you to get the 5 hours in. Yep. Yep. Thanks for asking. Yep. So we have work to do. It would be nice to be able to have that extra day, you know. If it was Good Friday, we could have done it. All right, so let's take a look at this full question. Ability to do work is energy, right? Energy, ability to do work. If you're having a laggy computer, if you want to answer the questions in the chat, you can also do that as well. You can do that as well. All right, DeAndre, still waiting for you to put down energy. There you go. All right, next question. So whenever I see it, we'll talk about it. Okay. So this one is energy. The object is based on movement. So that is kinetic energy. Remember, kinetic energy is movement based, right? Kinetic energy is energy of motion. All right, next question. Let's see here. Can we get, oh, guys, you're getting really quick on this one. By position, right? Position is potential energy. Position is potential energy because you raise something up as a potential to fall. If it has the potential to fall, it causes some damage. It's so kinetic energy is the when you have motion. Potential energy is when you are storing something up. So, all right, so energy from distance above the ground, remember that's gravitational potential energy. There's also chemical potential energy. The energy in a granola bar is potential, All right, so this is gravitational, just the height off the ground, okay? Height off the ground. Oh, wow, we got a few more people in there. Thanks, John. Thanks, Kylie. Thanks, Gabby. DeAndre, your computer's laggy this morning, or your Wi-Fi is. I have that happen. They just won't let you answer. Just takes too long to load. Wish this was a better situation. All right, so what is the answer? Question here. Sum of potential energy and mechanical is mechanical energy. So sum of kinetic and potential is mechanical energy, right? And we'll be talking more about that in the future. Hopefully it won't be so much asynchronous because we have 2 or 3 weeks of asynchronous classes coming up on April 9th. So potential energy. All right, so we still need DeAndre and Kylie. So this is, oh, there's DeAndre. It's mechanical energy is what we're looking for. Mechanical energy. There we go. All right. And this one, what are we going to talk about here? Come on. All right, this one's pretty straightforward. Energy stored in the nucleus is nuclear energy. Nuclear energy. Nuclear energy. Got that one, though. Computers are working good today. 7 out of 11. All right, you guys are getting those pretty fast. Chemical bonds, yeah, chemical energy, right? Energy stored. Chemical bonds are chemical energy. So like a granola bar or a battery. A battery has chemical energy in its side, and that's what is stored. There we go. Chemical energy. All right, full question. Energy units is a joule. We're using joules. Newtons we used for force. Now we're using joules. And watts we'll be using here on Wednesday. We'll be talking about watts. And that's power. So we do have a little few calculations today. All right, next question. Two more, three more. All right, kinetic energy that comes from vibration of particles. Now that's thermal energy, right? Thermal energy is where you're vibrating particles and getting them heated up, and they move faster. Rachel's on top of the lead there. All right, electromagnetic radiated emitted by hot objects. That is light energy. So think about hot objects as the sun. The hotter it gets, the color changes, right? So red is a low temperature, where now it's white hot, right? It's pretty hot. Next question, last question of all, right? So this one is, what is this one? Come on here. All right, so this one is energy in the form of vibration moving through something like water or air or solids, and that is sound. Sound vibrations. Sound creates vibrations through something, so that is a sound. Okay, so how do we do? Who won that one here? Rachel, looks like you did. And the winners are, wait for it, wait for it. Chloe third, and Rachel first. Gasaya, I don't know if I'm saying that right. Gasaya, is that right? How do I say it? Gasaya. Hey Blake, good to see you. Good job, guys. Excellent. Okay, so what we're doing today, we're talking about work. All right, so to do work, we explain how work is different from the work that we're talking about. Going to work, I go to work and sit in front of this computer, make lesson plans. All right, so explain what work is and what it's not, and how to calculate it. So that's our goal today. All right, so what does work mean to you guys? What does work mean to you? Thanks for getting in there, ladies and gentlemen. When you think of work, because unfortunately, in science, they're using a word that we use often, and we often talk about going to work. You know, maybe working at McDonald's, flipping burgers, or you know, doing something that gives us money. Yep. When you move, someone put down when you move, energy used to perform actions. Yep. Okay. Labor, right? So labor, something that you think of when you go to work. Energy being used up. Uh, energy used to perform actions. So yeah, there's some science in that as well, because you can see how it does work. I'm just sitting in front of this computer and I'm being bombarded by electrons from the computer screen. So um, so for work, many of us use work to earn money, but work is also means force used with your muscles. Someone might say they've done work when they push hard against a wall that doesn't move. However, in science, the word work is used in a different way. So remember that a force is a push or pull. Work is the transfer of energy that occurs when the force is an object moving. If you push against the desk and nothing moves, you haven't done any work. All right, so there's a force and actual movement. So you have to move something in order to get it to work. You might be exerting yourself, might be expending some energy, might be sweating trying to do it, and it's impossible to do, but you have to actually touch it and move it. All right, so what do you think about this one? Is work being done in this situation? You're pushing on a wall, the wall is pushing back on you. That's Newton's third law, but you are not getting any movement, right? If the wall is not moving, all right, most of you guys, thank you guys for getting in there. Thanks, DeAndre, Carmen, Chloe, Grace, Rachel, thanks so much. How about you, John and Journey, Chloe, Madeline, Natasha, I think that's right. Blake, Gabby, what do you think? Yes or no? Thank you for getting in there, ladies and gentlemen. Got eight people out of 16, so we got 16 people in here. I had more first hour. I don't know what happened here. I got like 21 people first hour. It doesn't usually happen that way. So most of you guys got it right. This is no. The work is done in above situation. No, because we have to move it. All right. So if we take a look at this, let me show you this picture here. Where is it? Right there. Slideshow. I'm going to show you the slideshow of a few things that have some movements in them. Okay, so if you look at this, the two conditions must be satisfied. The applied force must make the object move, and also it has to be in contact with it at all times. And there is a moving in the same direction. So this one is being pulled, the applied force, the distance of 5 meters, right? And it's going in the same direction. So this would be, if I look at this would be how we figure this out. It is work equals force times distance. All right, so here is the distance, the force is 50 newtons, and the distance is 5 meters, and there is a contact force going on here, so this is going to be 250 energy units. It's Newton meters, but we're going to call it joules. 250 joules, straightforward. Force is like mass is equal to, or force is equal to mass times acceleration. Now we have work is equal to force times the distance. So you remember that this one is F equals ma, so you can even break it down even further. If they give you the mass and the acceleration, then times the distance. Okay, so two conditions. One, the applied force must make the object move, so you have to be touching it, have to be pulling on it at all times. The movement must be in the same direction. So notice that lifting these set of books up is applying a force as you go up, and the distance, so it's going in the same direction. When you carry books while standing, you might think that your arms are doing some work. However, in this case, notice that you're walking in this direction, right? And the force that you're holding the books is up. So this is not work, no work done here, at least in the case of physics and how we do things. Okay, so there's no work going on in here. All right, so let's ask you this question here. So let me go here. All right, so let's take a look at what we just said. So which of these does work? I can tell you there are two of them that are not work and two of them that are work. Remember that we're looking at the direction of the force going in the same direction as the motion. So which of these is it A, B, C, or D? And all right, so we've got somebody that says, so remember there are two of them there. Okay, which ones are they? Okay, so let me help you out here. So if I take a look at this one works, right? The force is you're pushing on it to the right, and the motion's to the right. This one does not work. This one does. Pull force going up, and the direction of the motion is up, and this one doesn't work. Okay, so if you put down A and C, right, you got the correct idea. So direction of the force, direction of the motion have to be parallel to each other. All right, 6 out of 15. Very good, guys. Thank you much. Who else came in here? We have 3 more people. All right. Rachel. No, not Rachel. No, I was thinking Stephen. Stephen came in. Good to see you, Stephen. And I had 12 before. Now, who else did I see I did not say hello to? All right. I think I said hello to everybody. Okay. All right. So going back to this idea here, just kind of want to reiterate this idea that when we look at something that's going in this direction, so notice that if you give a book a push and it slides across the table for a distance 1 meter before it comes to a stop, even though the book is moved to 1 meter, you did not work on the book while your hands are on contact with it. So here they're pushing things back and forth on the table, and even though you'd think there would work there, you'd have to, if you just slid the salt and pepper shaker over by hand, that would be considered work as long as your hand is touching it, right? But without doing that, you need to have that. When work is done, energy is transferred. So energy can be transferred in a lot of different ways. So you feel like you're carrying a box up a flight of stairs. You're doing work because you're carrying it up. You're pulling it up to increase the potential energy by the height, right? So your more potential energy and kinetic energy to come later. Yeah, we'll be talking about this later. Right, so here energy, the ability to cause change. Now, this is not considered work by just pushing it. Boy transfers energy from the muscles to the car, but work is not being done because unless they're holding on to the car, right? All right, so we're going to look at some equations here, and the amount of force done depends on the amount of force exerted and the distance. Okay, so these are pretty straightforward. They look like just about any of the equations we've ever done. Force is equal to mass times acceleration, works the same way, right? So in this equation, force is measured in newtons, distance is measured in meters, work will be like energy is measured in joules. 1 joule is the amount of work required to lift a baseball a vertical distance of 0.7 meters. So they have some form of that. So again, like we said, work is force times distance, right? And again, I can do some things with this. So if I cover up the work with my finger, then I'm going to see that I have to take the force times the distance, right? So here we've covered up the work. We've got 2 meters, 2 newtons. Force of 2 newtons measures an object, moves an object 3 meters. So let's take a look at what happens here. So 2 meters times 3, 2 newtons times 3 meters gives us 6 joules. 2 times 3. All right, let's have you guys try this one. All right, so let's do this one. What work is done here? So let's work on this one together. So we have 12 newtons. So force, 12 newtons, times the distance of 0.5. And then you're going to get the answer in joules. So put the letter J by it. All right, so 12 times 0.5. So what do you get when you do 12 times 0.5? Put that answer in the, there you go. Thank you much, Rachel. 12 times 0.5, you get something with a J in it at the end. All right, good job, guys. How about you, Stephen, Renaya, Natasia, Madeline, Kylie? 12 times 0.5. Use your calculator, right? I always get about half as many people when it comes to multiplication problems. All right. All right. So let's move on from here. So this one was 6 joules. Okay, so let's do one other one, and then we're going to stop right there. It says, what is, if we have 500 joules of work, we're moving in a refrigerator 5 meters, how much force is needed? Okay, so we're going to cover up the force with our finger, which tells us we take work divided by distance. All right, so let's see if you can figure this out. So it's 500 joules divided by 5 meters, and we're going to end up with a Newton, right? Because really what this is, work is a Newton meter, and distance is in a meter. Those cross cancel, so we have blank newtons. Ah, there you go. A couple people got there, 4 out of 15. Thanks so much. I really do appreciate the help on this, that you guys are participating. It helps me figure out that you guys are understanding, all right, finding what the information is, or even just making sure that you are in the class. You might be just sitting in the background, right? So answer is 100 joules, right? 100 newtons, 100 newtons. Okay, so that's where we're going to be today. Most of your vocabulary, most of this week's work is vocabulary. So let me go here and go to another screen here, default. Okay, so today's assignment for you guys, if you haven't done it already, is to work on W9, assignment 1 and 2. 1 and 2 are due on Thursday. Okay, they're part of marking period. They're going to be included in part of marking period 2. This is marking period 1. This is quarter 2, marking period, right, 1. Okay, so the grades are going in. So just to remind you guys that Friday is asynchronous, and I'll have a video with some questions for you, something like an Ed puzzle. I wish I had the technology that they have when they do these YouTube videos on these. All right, so Friday's asynchronous. They'll have an assignment there. Remember to get your 5 hours in. All right, so there is also an exit quiz today on forces. Okay, let me get you that real quick here. So the exit quiz is a Google Form. So make sure that you take a look and take a screenshot of that. Okay, so let me do the public chat here. Let me clear the chat out. So exit quiz is here. Right. And if you think about this, bonuses are due on Thursday too. Bonus ones are due on Thursday. So anything bonuses are due this week, right? So they can add up to 50 points onto your grade. Bonus 2 will start the following week. Okay. All right. So I will give you, if you need some help on the calculations of work, and we can go over some problems in the big blue button. And I'll give you that link here in a second. All right, here is the link for you guys. This is the big blue button help session. So if you have questions about your grade or anything that you need some tutoring on or anything like that, just come in to the big blue button session here. Let me get that link there. This is the big blue button help. All right. That should do it for today, ladies and gentlemen. Thanks for participating.